Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel Higher Tier Paper 1 from June 2018. We're on question 19 at the moment, and we've got a question about coordinates. So we're given two coordinates, the coordinate of point P, which is 3, 4, and the coordinate of point Q, which is A, B. And we're also given that a line perpendicular to PQ, which would be a line drawn between P and Q, has got this equation. So we're asked to find, ultimately, an expression for B, so B from the coordinate here, in terms of A. So the first thing I'm going to try and do here is just have a look at the situation by drawing P and Q on a graph. So if we do that, we can see we've got P, has got the coordinates 3, 4, so the x coordinate is 3 and the y coordinate is 4, and so that would give us point P there. And then point Q has got coordinates A, B. Now we don't know what they are yet, so I'm just going to put them on there and imagine we do, just so we can work on the question. So I'm going to say that A is here and B, the y coordinate, is here. So that will be point Q. And there we go. That's our line, which is PQ. The next thing that we're given here is that a line perpendicular to PQ has this equation. So perpendicular actually means it's at 90 degrees. So this would be an example of a line which is at 90 degrees or is perpendicular to PQ. And what we can do, given this equation, is we can find the gradient of this line perpendicular to PQ, and then from that we can find the gradient of PQ. So taking this equation here, 3x plus 2y equals 7, what I'm going to try and do is put it in the form y is equal to mx plus c, which is the standard equation of a straight line, where m is equal to the gradient and c is equal to the y-intercept, which means where it crosses the y-axis. So taking this equation then, 3x plus 2y equals 7. The first thing I'm going to do is I'm going to take away 3x from both sides. If I do that, that will leave me with 2y equals, and I put the negative 3x at the front there, 3x plus the 7 we already had. So that's the effect of taking away 3x from both sides. Next thing I'm going to do is divide through by the 2. So if I do that, the 2 will disappear here on the left, and I'll get minus 3 over 2x plus 7 over 2. So what this tells me is the y-intercept for this is actually 7 over 2. And what we can very usefully find is that the gradient of this one, m, is actually equal to minus 3 over 2. So that's the gradient of the line perpendicular to PQ. To calculate, which is what we're going to do now, we're going to calculate the gradient of PQ, we need to use a relationship between the gradients of two lines that are perpendicular to each other. So if the gradient of one of the lines is given by m1, then the line perpendicular to it with the gradient m2 is minus 1 over m2. So that's the relationship between two perpendicular lines, the gradients of them. In other words, what that means is the gradient of PQ is this gradient here turned upside down, and then the sign of it changed from a negative to a positive. If it had been a positive sign, we'd change it to a negative, so we'll just change it to the opposite. So the gradient of PQ is 2/3, and it's a positive 2/3, because the negative changes to a positive, and what we do is we turn this gradient upside down, so it becomes 2/3. So that's the gradient of our line PQ. there's another formula we can then use for gradients, and this is the formula for the gradient of a line between 2 points, which is what we have here. If the 2 points are, I'll call them here x1, y1, and x2, y2, then the gradient between those 2 points would be given as y2, so the second y coordinate, minus y1, which is the first y coordinate, over x2, second x coordinate, minus x1. So since we do have these coordinates either in the form of numbers or in the form of letters here, A and B, so what we can apply this formula. So what I'm going to say is x1 here is the 3 and y1 is the 4. So there we go, x1 equals 3, y1 is equal to 4. And then since this is our second coordinate, we can say, well, x2 equals A and y2 equals B. So what I'm going to do is substitute those into here. So what I'll get is y2 is B, so it's B minus y1, which is 4, over x2, which is A, minus x1, which is 3. And since we already know the gradient is actually 2/3, we can then create an equation. We can equate that to 2/3 there. So that gives me an equation we can use to find the value of B in terms of A. So what I'm going to do is I'm going to take this A minus 3, put it in a bracket there, and I'm going to multiply both sides of the equation so that it disappears on the left-hand side and ends up multiplying the 2. So what I'll end up with is B minus 4 is equal to 2A minus 3. Then what I'm going to do is multiply through by the 3 that I've got here. So put this in a bracket. I've got 3B minus 4 equals 2A minus 3. Now what I'm going to do is just multiply out the brackets. So I will get 3B minus 12 equals 2A minus 6. So multiplying every part in that bracket by the 3 and every part in that bracket by the 2. Now what I'm going to do is add 12 to both sides. So if I do that, I'll add 12, and I'll continue up here. So what's going to happen is we'll end up with 3B on its own, and that will equal 2A, and this time should be a 12 there, 2A plus 6. So all I need to do then is get rid of this 3 in front of the B, and so I can do that by dividing both sides by B. So divide this side by B by 3, the 3 will disappear and just leave B on its own, and I'll end up with 2/3 of A, and I've got to times divide all parts by the 3. So if I divide the 6 by 3, I'll actually get 2. And that's it. We've done it. We've got B is in terms of A, which means we've got an equation. B is on its own equal to a function of A, 2/3 A plus 2. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, which is Gary Teaches Maths. And for more help, look at our website, which is just appearing at the top of the page now, which is bestmathstutors.co.uk. Thanks for watching.